So, managing cyber risk across XIOT. Everyone's going to say, what's XIOT? Let's start with first, what is the modern industrial site today? Everything is a physical system that's connected. From the lighting system, fire alarm system, CCTV systems, elevators, all the way down to the actuators, the sensors, the pumps, the HVACs, you name it. Everything is now a physical system that is connected within an environment, which we call the extended Internet of Things. Whether it's the operational technology, which drives the HVACs, whether it's the IoT devices like the CCTV cameras, elevators, etc., everything is now connected. This threat landscape is now huge. The rapid proliferation of what we call cyber-physical systems has been going since the dawn of the Industrial Revolution of 3.0. Ever since the 70s, we've seen this connection of automation technologies and programmable logic controllers that effectively improve the performance of production. Make them more efficient, make them faster. The first ever malware was something called the creeper worm in the 70s, which effectively got into the ARPANET network and replicated itself to effectively say it was the creeper worm, can you catch me, and bounced from a replication from one system to the other. That was the first malware within an environment. Obviously then, as you get the internet, start getting connectivity, you can start to drive interconnected supply chains, systems can start to talk to each other, whether that's the conveyor belt, to the box packaging system, to the logistics system within a warehouse or production facility. Things are starting to get connected to be more efficient, to move faster. Because us, the consumers, we want more things fast. Right? Everything's just in time. Obviously, as you start to get into what we call Industry 4.0, which we've been going through over several years, IoT has become a seriously sort of connected, extensional threat surface. It's become its own fabric. The connected devices of IoT, I think, range around 1 million devices every hour. If you look at then what has happened in terms of the malware that has started to affect these environments, these industrial and IoT-based environments, that have started to impact this smart manufacturing revolution that's been going through 4.0, it has been on the increase. Since 2013 until last year, half two, a 3,900% increase has occurred. I think we're on the 5th anniversary of NotPetya. We have started to see more and more impacts to the industrial environments over the last year, and we are really on the cusp of the Industry 5.0 revolution, where we start to see cognitive cyber-physical systems interconnect and learn from each other to be more efficient as companies become more focused on how do they drive down their energy efficiency, how do they start to drive their performance in terms of their ability to drive uptime and business continuity. These things are getting smarter, they're getting more connected. Therefore, this is the dark side. No native IT controls really sees these environments and these operational environments. It's a different language, it's unfamiliar protocols, it's an unfamiliar environment, it sits below the SCADA, it's sort of forgotten in some cases. If we think about a couple of stories here, thinking of the Colonial Pipeline attack, which occurred last year, the impact really hit society. They were unable to prove that their operational environments were secure after a malware impact from DarkSide. So they had to shut down the pipeline transmission. What that did is that then stopped the petroleum shipment up the east coast of the US. That stopped petrol getting to the fuel stations, the gas stations, that meant that us, consumers and commuters, could not fill the vehicles to get to work. I mean, that was a one impact on operational environment which actually hit us in society. So we're talking about protecting our society by protecting this operational technology, this IoT environment, and what we've grouped together as the extended IoT. It doesn't just stop in industry. If you think about healthcare, we're talking about blood analyzer machines, we're talking about MRI machines. These clinical assets that that are within a hospital environment, which protect and save lives, very expensive, all interconnected, all need to be protected. We've seen some attacks on hospitals that have really taken people's lives. And then you start to think beyond the medical and clinical engineering device. If you can't get into a building, or the hospital doesn't have the power, doesn't have the air conditioning, doesn't have the elevators working, patients can't get to those MRI machines. So you've got to now think about not just the clinical engineering device, but also that building management solution that is around that environment that makes everything work, i.e. the modern connected environment. So what are organizations looking for? They're looking for digital safety. Cyber resilience, we call it in the cyber world. Digital safety is what it's referred to within the industrial environments. Effectively, how do they look at their environment, make sure that they are monitoring those vulnerabilities that they've got within those programmable logic controllers, remote terminal units, what's high criticality from a vulnerability that's already been found, all the way through to what's end of life, what's unmanaged. How do we start to deploy a zero trust environment to understand who is accessing my environment, doing my firmware updates in my industrial environments? When are they doing that? Is it on a maintenance window? Is it really a true automation and support OT engineer, or is it a bad actor coming in through a back door? Then there's operational resilience, process integrity. Is that programmable logic controller speaking to that engineering workstation, to that programmable logic controller, actually doing what it's supposed to be doing? Or is someone now using tool sets to come into my environment and mimic my operational environments? There are some tool sets out there, Dusty Tunnel, Mouse Hole, and there's others which can get in through your operational environments and allow you access. And if IT can't see that, and the OT engineer is just focused on health and safety and not thinking about the cyber resilience of that environment, you have a bad actor moving around, mimicking your environments, mimicking your actions, within your environment, you don't even know it. And then they've only got to deploy something like a bad omen, which is a Schneider-focused malware attack within an environment, to be able to create denial of service on your Schneider PLCs, for example, that effectively shut down your operations. What has happened is that the bad actor has moved from using personal information as a way to drive monetary return to now looking at business availability as a way to leverage return, uptime, because they know it can now affect any company, not just the financial services organizations where they used to go after that information, for example, and really have a leverage. They're now saying, well, we can now attack any organization because if we shut down their operations, we've got huge leverage on them to be able to get that monetary return. And what we've done, and you'll see at the end of this presentation, is we've been paying these ransoms. So we've been investing in a DevOps groups which have now become so far advanced that we now have to really start to step up in terms of our ability to respond to these malactors. Otherwise, our lives as consumers and the industry and society as a whole across the economy is at risk of losing its availability and its uptime. Operational resilience is critical. We need to leverage our knowledge to go down and start to protect these operational IoT and extended IoT environments that are now part of an interconnected society. So the journey to achieving these business outcomes, and this is as per Gartner's view of what is that journey. First of all, it's an awareness, understanding that this interconnectivity is occurring, that you have an operational uptime risk with this connected threat surface that you've now got within your environment. 60% of organizations are at this stage that are recognizing, committing, and now focused on how do I address this? There's been this shift, or this polarized shift from those operational supply chain, COO responsibilities into the CISO now for this connected threat surface that's now looking at how do I address this dark side, unfamiliar protocols, I can't patch it, it's firmware, I need to go in, I need to start to monitor this environment, I need different tool sets. Then there's visibility, what Gartner calls the oh wow moment, really, which is where you start to see, I have a third of my environment that has high criticality, CVE matched vulnerabilities and I need to address them because these are all known vulnerabilities that are out there, and I'm using all this great open source Ethernet IP protocols to sort of communicate across all my automation assets, but actually it's already got a whole load of vulnerabilities that are known, and pretty much there's probably malware out there that's going to approach it and attack it. Then there's the firefighting, addressing a program, engaging with transformation-based partners that can help them go on this program of, okay, how do I take those high criticality assets? How do I move from what is my inherent risk to a residual risk that I'm willing to live with for whatever environments it may be? Then it's now starting to get that whole GRC integration. How do I start to deploy the 3 lines of defense and put my OT environment as my first line of defense, integrated into my GRC program, making sure I've got that integrated into my SOC, and then I've got my audit committee that's making sure that I've got that revalidation going on. And then optimizing. How am I looking at my asset utilization? How am I looking at my environments? How do I start to then optimize the highest level of performance in terms of my security controls across all of my interconnected assets and environments? Just a little wind back. This is a bit of the double click on a discovery reality. Today, it's manual. Walk down. People are walking down factories, cataloging assets, putting them on spreadsheets, doing partial inventory, looking at project files, understanding what they've got. Is it an ABB, a Schneider, Yokogawa, Honeywell, Rockwell, Siemens? What sort of assets have I got within my environment? Then they realize they don't have any tools to look at this environment, really have a limited understanding of what that risk is, because cataloging those assets and trying to match them up against vulnerabilities, extremely manual exercise. And then ultimately, how do I start to monitor this environment? So I've got no threat alerts coming out of this environment into my traditional threat monitoring systems on my corporate IT environments. It's not an endpoint that I recognize as an endpoint as an IT laptop, for example, or a mobile device. There's a real lack of the network traffic information. What is actually happening between these environments? And that means there's collaboration, and there's this real convergence that's happening between the operational technology team and the IT network ops and security teams to have to work together to understand what is communicating to what and why, and is that accurate? And they have to do that manually through engagements, having 2 teams, sometimes remotely spread across the nations and global environments, because you've got your headlights being produced in one country, for example. If I take an automotive example, your engines in another country, your bodyworks in another country, your hoses in another country, and it's all part of an interconnected supply chain to come together to ensure that your vehicle or a vehicle is produced every 30 seconds off the factory line. All of these interconnectivities and systems means there's a lot of collaboration, which is very manual today. I'm going to go back a little bit to the building example, just to make it clear. Just look at this and think. You've got modern buildings now, solar panels, elevators, cooling towers, water supply systems, power distribution, backup generators, pumps, gas heating, air conditioning, fire alarms, in some countries, seismic controllers. All of this interconnectivity that used to be very siloed, that is now extremely converged. If you took down the power system of a building, you can't produce anything. You start to tamper with the fire systems, next thing you know, you've got extinguisher powder all over your factory floor, you've got a health and safety hazard, a lot of risks. So how do we take this journey? First of all, the visibility and the wow, where we talked about 60% of the organization at least are in this phase. You've got to start to get that asset discovery. You've got to use the right tools in these environments that can speak with the proprietary protocols that are required to collect this asset information. Then start to look at what are the CVE match, what is my end of lives, which are my high vulnerability, unmanaged environments, and start to build that risk and vulnerability management view of your environment. Then from a network protection perspective, you start to use the tools to start to create asset class segmentation, even role-based access segmentation. Who can access these environments? What these environments do when they talk to each other? Who can talk around this process automation, control, communication, integrity? Then start to look at the threat detection. It shouldn't be done at the end of the cycle. You've got to start to think about, how do I start to look at the anomaly behaviors of the environment, whether it's DNS, blacklist, for example, using signatures, using other methodologies in terms of the usual behavioral patterns of your operational and IoT environments are generating then potential alerts to feed into your traditional security operations center for monitoring. Start small, otherwise you'll wait to the end and you'll have to start doing the whole thing big. The journey to operational resilience. Again, it all starts with that asset discovery. Then moving into asset management. How do I now decide who owns what assets? Because I think you'll find if you speak to anyone, they don't really know who is the owner of what assets within their operational and IT environments. And I can talk about a story, a bridge, a huge famous bridge, has about 400,000 cars and passengers going across it every day. There's connected seismic controllers, there's connected heating and monitoring systems with connected extinguishing systems, all part of an insurance requirement to make sure that it's connected to protect the bridge and protect the citizens that are crossing that bridge. That system was down for 3 or 4 days when we went in to help this client, and they didn't even know who owned it, didn't know who to go to find the person that could then go to those environments and start to work on how we get them back up, how do we start to make sure they're monitored, how do we start to get the insurance valid again, how do we start to get that citizens and society protected again. Finding the asset owner is sometimes the most difficult. Change management. Making sure you've got an effective process to go through the change, because you're going to start to change from where operational technology and plant leaders and engineers are thinking about the process integrity, the health and safety is primary in all of these environments, whether it's a nuclear power station, an oil rig, to a manufacturing floor. To ask them now to think about the cyber resilience and the operational resilience and start to communicate with IT, where they've sort of said, that's IT's world, that's not their world, that's not my world is here. We have to sort of drive this change management in organizations around people working together, collaborating, because we need to drive a safer society. And that means we need to work and collaborate together with the right tools to protect this really heavily connected modern enterprise and industrial environment. And then remote access. More and more, we're starting to see these back doors open where third-party automation vendors and OT engineer operators now working from home or working remotely because of various plants in different countries and regions are accessing through back doors using jump boxes and different ADs, domains to effectively get into the environments to then start to monitor and support the engineering workstation, which controls all the programmable logic controllers and remote terminal units and actuators and sensors. We've got to figure out who's accessing when and what are they allowed to see. Start to really drive that sort of zero trust culture into your environment by protecting who gets in. Just wanted to give you a little bit of a flavor of very, very high level, sort of an anatomy of an attack. Now, I'm not talking about some of the recent sort of malware, and you start to look at things like Triton, Trisys, Indestroyer, InController, all these sort of modern, latest industrial malware environments, or even some of those real cool sort of malactors tool sets like Dusty Tunnel, Mousehole, and Bad Omen, and several others that can really sort of get into your environment. But at a high level here, effectively you've got an intrusion into your environment because an OT engineer has just carried out a routine exercise on his workstation, a Windows environment. And what you'll find is that most engineering workstations, and this is true for medical environments too, those Windows machines are several versions back because a lot of these sort of firmware controllers have been built on an operating system logic and communication path of a Windows OS that was, 3 or 4, maybe even 5 versions back, which means they've already got known compromises. But to update the firmware and get it operating in the operating system takes evolution and change. So you've got a lot of compromises in there. Then, obviously, the attacker can get in, you through the Windows vulnerability. Then you can jump to the subnet. Obviously, it's not seen, not monitored, nobody knows. It's getting access in, starts to deliver a payload. We're talking about combining physics with a cyber payload. And if you think about, I'm going to pick Oldsmar Water, which was in Florida, where somebody accessed and combined a physics adjustment by trying to adjust the chlorine level in the water that effectively could create a poison effect on a complete county in Florida. This is now a different level of warfare in terms of the industrial environment and the way in which we need to respond and protect ourselves. So how Claroty does this, company I represent, is that we obviously have a tool set which is identifying and cataloging the assets. It's looking and already matching up to a library around what are the vulnerabilities from a CVE matching, end of life, high criticality, but it also starts to look at and learn the behavior, because we have over 6,500 sites deployed globally across multiple organizations around the world. We've built up a level of machine learning that knows what this Siemens controller should be doing with this ABB controller or this Yokogawa through this engineering workstation. And we can start to see and we can identify an anomaly activity through that learning. You can also put the tool into learning mode and learn your own environment, obviously drive those alerts. And you can also check for signatures, Yara, Snort, and any other sort of custom rules you want to apply. But ultimately, it creates that recommendation that there's been a policy violation. Then, through straightforward syslog, SIF format inputs into your SIM, you can create that monitoring, and you can start to respond to it and figure out how to remediate. Now, that sounds all very simple, but that's a hugely complex number of individuals and teams that all need to work together to get this level of protection. But we've got to start somewhere. As I said, Gartner said that 60% of the organizations are out there looking at the awareness, 30% are on that sort of next stage of risk management, only 10% are at that stage where they're really monitoring those environments and responding and remediating to those threats. So here's just a quick example from multiple industrial verticals that we have clients in, that we operate in, and ultimately how they're looking at that journey, and whether that's heavy industry, whether it's technology OEM clients, mining, chemical production, energy utility and distribution, or the transportation and logistics. Think about the top challenges here. Again, asset discovery, understanding that inherent risk, because if you want to move to a point where you want to get to a residual risk that you're willing to live with, you've got to understand what my current inherent risk is before you start to set what the bar that you're willing to live with. Also seeing more and more that cyber insurance companies are now demanding this requirement to have this level of protection. So you've got this sort of regulation that's coming through NIST. You've got this regulation that's going through various other industry-specific verticals like NERC-CIP and others, for example, in renewables. But you've also now got this insurance market now driving this response and action that you've got to address and make sure that you've got the right level of protections in your environment. You've got a very complex network communications, and sometimes some of these network communication environments are so legacy, so out of date, they don't have the bandwidth. I mean, you're talking about maybe sometimes a janitor's cupboard that effectively is operating a network environment in some of these industrial sites. I think the knowledge gap is a critical one, and I applaud all the partners and service providers and clients out there that are focused on driving up the OT cyber skills capability, because we're never going to be able to make this shift to defend society, defend us as the consumers, and protect ourselves against the malactors who are now targeting organizations because of the availability and business continuity for reward, unless we drive the skills and we get the right skills within our environments and our people. Again, outcomes, cyber resilience, digital safety, operational resilience, process integrity. So a recent CISO survey that we did, 80% of organizations have experienced a ransom attack. Roughly 500,000 an hour downtime impact. I've seen some at 5 million an hour. I know it sounds really crazy, but if you start to not be able to produce vehicles every 30 seconds, it gets to a point where you can only fill up the car park of unfinished vehicles before you have to stop productions and send the workforce home, because you haven't got the hoses coming in just-in-time supply, because your supply chain has been impacted and taken down, they can't produce hoses, for example. 50% of ransomware payments were more than $500,000. This money is going straight into improving the skills, the DevOps, the capabilities of these malactors. Let's spend that money on protecting our environments and not giving it to them, so that we can start to get ahead of the curve and get ahead of them and start to really push back. 50% resulted in substantial site impact. Substantial site impact. 88% are struggling to find OT cybersecurity expertise, going back to the fact that we have a shortage in OT cybersecurity skills and capabilities globally. And I'm going to tell you a story. A vending machine manufacturer, okay, puts vending machines in railway stations. They've got these great little sort of ear pods, everything else that you want to sort of buy, credit card, all convenient for us. We're whizzing through the airport. I've lost my AirPods. Let me get some more AirPods. Tap, tap, tap. That vending machine has a call home to the manufacturer, to the production facility, to let it know if it's down or there's some sort of firmware problem that's in that environment. And obviously, they then monitor that, and they also take that route of path for the credit card information to go through the corporate IT environment. We helped out a customer, and we identified some sort of suspicious traffic that was coming from the vending machines on the railway sites into the production facility, out through the production facility, and to an unknown IP. And when we looked at this unknown IP was in Iran. And we started to dig in and understand what it was, and we worked with them, and they worked with us. And we found out that there was a back door coming in through an automation vendor's port, through a jump box, effectively to the vending machine, which was stealing the credit card information off the back of the vending machines. Completely unknown to IT. Completely unknown. Didn't even know. Obviously, all of the IT security tool sets they had didn't even pick it up. Obviously, shut that back door as soon as possible, close it down, et cetera, et cetera. But it just to give you an example of just how invisible this is from an environment that we need to address. So I'll finish with who is Claroty. We're headquartered in New York. We were founded in 2015. We have investors in us like Rockwell, Siemens, Schneider, really the automation vendors that want to protect society. We've a funding round of $635 million Series E. We have over 600 clients globally, roughly 6,500 sites, 3,000 hospitals, 50 countries, and we provide a tool which can do that entire life cycle of protection around the IoT and the extended Internet of Things. We have leading awards. We were recognized as the leader in the Forrester Wave, the first analyst firm to come out with industrial control system security evaluation last year. Outright leader. Best in class, 2 years running, which is the healthcare equivalent in terms of assessing healthcare security monitoring. And with that, I hope you enjoyed this presentation. Thank you very much for listening.
Thank you so much, Simon. That was just a fantastic presentation and really made the whole challenge that you are going through as an industry live, actually. Excellent, excellent. Is there anybody in the room who'd like to ask Simon a question? We can get a mic over to you if you have anyone? No? Okay. All right. I actually have a question for you. I was reading yesterday, there was a story in the Mail about an 18-year-old who has just been sent down for sending out a malware virus that has taken down several banks in the UK. And sort of when I'm in this sort of situation with, sort of looking at cyber and how it's operating, and I see that we have such a young generation growing up, and they are just so cyber savvy, and they are so tech savvy, and they are so able. It it's a huge challenge for companies to kind of manage that situation. How are you, I mean, how are you sort of drawing on sort of bringing young technicians into the industry so that you can kind of channel that brilliance, as it were, to almost counteract the problem?
Yeah, I think that the younger generation, and I probably also refer to my son as well, who's 11 years old and using C# and visual and coding. Coding language is natural to them. They're starting to use more and more sort of applications which allow them to build, experiment, use codes. So as they start to become more capable, they also find it fun in finding weaknesses in other people's code and vulnerabilities in other people's code. And that then starts to sort of breed this sort of cat and mouse of, okay, well, I can be better than you by taking down your code and so on and so on. So the way in which we need, I think, to focus on not just the OT and IoT cybersecurity skills is we've got to really drive a curriculum of education across the younger generation globally, because I think we need to be much more tech savvy and cyber aware, specifically within the younger generation. For example, my company has created the Claroty Academy, which allows people to come in and effectively educate themselves on how and what is OT, all the way through to how to sort of implement, how to sort of support, how to sort of architect, understand, and analyze environments in the OT world. And I think there's been a few universities that have started to create now this IoT and OT cybersecurity capability. But I think they're going from an engineering focus. So traditional engineering curricula, for example, is now being, I suppose, enriched with that digital cyber safety piece. And I think what we've got to do is on the other side with the tech curricula is start to bring cybersecurity into the tech curricula. And I think if we can do that, we'll start to breed a new generation of warriors that can go out there and protect society against the malactors.
Okay. Thank you. Thank you very much. Thanks a lot, Simon Chassar.